Okay, here's warm-up number 14. We got some algebra review here. I've got the equation. This is a linear equation. It's the equation of a straight line. This particular equation is in slope-intercept form. So maybe you remember y equals mx plus b. So m is going to be the slope, and then b is going to be the y-intercept. Okay, so since it's already in that format, you just have to know where to look. Hey, this is the m part. It's where the m is, so that's the slope, 2/3. There we go. Y-intercept here is -1. Remember, the negative goes with it. It's not just 1, right? Because, yeah, it's adding b, so b would be -1. All right, so there's my slope and my y-intercept, and that's the key to graphing this line. So start with the y-intercept. That means, hey, here's my y-axis. My line's going to cross the y-axis at -1, so down 1. So make a little dot right there. I know my line goes through that point. Then I'm going to use the slope to find another point. So the slope is sometimes referred to as rise over run. So that just means I can use, if you've got a slope in fraction format, you can use the slope to get from one point to any other point to another point on the line. So that means from this point, I'm going to go up 2, because that's the rise. If it were -2, I'd go down 2. And then run means left and right. I'm going to go right 3. So I'm going to go up 2 to the right 3. Not from the origin, but from a point that I know is on the line, which is this point. So I'm going to go up 2, 2 units up, 3 units to the right. There's another point. I could do it again. I could go up 2 to the right 3. Or I could go down 2 to the left 3, because -2 over -3 is the same as +2 over +3. But you only really need 2 points. Sometimes I see people do this. That's a line segment, not a line, right? You want to show that this goes on forever in both directions. But yeah, just get the 2 points and connect the dots, and that's enough. Okay? All right, next up, finding the length of segment CD. I should really have the little bar there. So I'm going to use the distance formula. So there's my first xy pair, and here is the second xy pair. All right, and here is the distance formula. It's the one under the big long radical. So first I'm going to subtract the 2 x's, and then raise to the second power. And then I'm going to subtract the 2 y's and raise that to the second. And I'm going to add together these 2 parentheses as well. Okay, so let's just start putting the pieces into this. So the distance between those 2 points is going to be the length of the segment, right? Okay, so let's subtract the 2 x's. I'm going to do -5 minus 0. You could have also done 0 minus -5, and that would actually get you to the same place after you do the squaring. So it doesn't really matter which way you subtract, but make sure those are your 2 x's. And then for my y's, I'm going to do -2 minus -3. I'm going to have a double negative here. So just beware of that. And again, you could have done -3 minus -2. And that will work as well. Okay? So I'm going to start with the parts in the parentheses. So that means I'm going to start by doing the subtraction here. That doesn't do anything there. So that's -5 squared. And then this would be -2 minus -3. That's the same as -2 plus 3, right? So this is going to come out to 1 squared. Okay? Now I'm going to do the exponents. I'm going to square. Some people will say, oh, the square root and the squares undo each other, so -5 plus 1. It doesn't work like that. You have to simplify everything under the radical. The very last thing you'll do is take the square root. So -5 squared is +25. Sometimes I see people write -25, but think of -5 times -5, a negative times a negative, right? And then I've got 25 plus 1. That's going to be 26. You could just leave this as root 26. It doesn't come out to an even number. It's a little more than 5, right? Because the square root of 25 would be exactly 5. Excuse me. This is going to come, if you put it in a calculator, it's about 5.1. Either way is fine for me. And there we go. See you next time.